Okay, let's take a look at a horizontal launch. So in this case, go ahead and take a look at these equations. Pause the video for a minute and figure out why these are true from your basic equations from our other videos that we've been watching. Initial velocity in the y direction is 0. Okay. Now let's take a look at that bottom equation, and we're going to rewrite that for velocity in the y direction is, take the square root. Gravity is, oh, we should have put a g on that one. Gravity is here. So the velocity in the y direction is the square root of 2g, and now of the height that's actually fallen. Okay. So if you're looking at the very bottom of the height, very bottom of the projectile at the ground, it's going to be h. If it's only fallen halfway, then it's going to be 1/2 of the h. Okay, so let's go ahead and do an example. Let's look at this scenario here. Let's say we have a height of 125 meters. Okay. So, given the height of the cliff is equal to 125 meters, initial velocity in the x direction is 5 meters per second, and we're given that it's horizontal. And unless otherwise stated, we're on Earth, so gravity, let's just say gravity is about 10 meters per second, and it's acting downward. We're going to assume, since everything is going down and to the right only, we're going to use our reference frame at the origin going down. Okay. So down and to the right is positive, okay, as shown on the diagram. And what do we want to know? Typically, we want to know how far it goes. So what's the x? We want to know the x. Okay. So what equations are we going to use? Not just one, but a couple of them. So the first thing we need to do, we want to know how far it goes. But in order to do that, we need our equation. It's going to go velocity times time. So we know this value. That is 5 meters per second, but we don't know the time. So we need to solve for this before we can use this equation. So to find the time, we know that distance is 1/2 at squared. And the height is going to be the distance in the y direction, and gravity is the acceleration. So we can now solve for time. Once we have the time, we can plug it in. So time, let's multiply both sides by 2, divide both sides by gravity, and then we'll actually take the square root of all of that. And we kind of showed that in the last video. So let's go ahead and plug the values in. Plus or minus, but we're only looking in the positive future here. And the height was 125 meters. And gravity is about 10 meters per second squared. I'm going to write second squared this time instead of second per second, because you can see where all the values come out. The units are going to be, meters are going to cancel. So you'll just get in the denominator for the units, we'll get 1/second squared, which is kind of odd. I could pull that into the numerator. And it's just second squared in the numerator. So whatever's in the denominator ends up being in the numerator. If it's in the denominator's denominator, we're going to have second squared. And you can see how time is going to be measured in seconds because the seconds unit is in the square root. So 2 times 125 is 250. Divide that by 10. We get the square root of 25 seconds squared, which is 5 seconds. So the object is in the air for 5 seconds. I then can find out how far it goes by plugging that 5 seconds in, and we know that the rate that it was traveling was also 5 meters per second, okay, in the x direction. So it will travel 5 meters per second for 5 seconds. The seconds will cancel, and we get 25 meters total that it will travel. Now, could we have a different scenario where we were, let's say we did not know. Let's rewrite it. If we did not know initial velocity. Okay? So let's say the height was 125 meters, and we knew that the object went 25 meters. Let's say we knew that originally. That was the given pieces of information. We could then, let's see, we want the initial velocity in the x direction. Now, we know what we're going to get is 5, but let's go ahead and take a look at it. Time is going to be equal to, and we can use this equation. This equation only works for horizontal launches. Okay? 2h over g. And since we have the same height drop, it's going to have the exact same value. So it's going to be 5 seconds. Now, when we plug it in to our equation, we plug in the seconds, we have the x value instead of the horizontal velocity. So we get 25 equals horizontal velocity, and that's the unknown. So then we're going to go ahead and divide both sides by 5, and we get velocity in the x is 5 meters per second. So you are set. You need to know both of these before you do any projectile launching type labs.